Hey everybody, this is Larry. This is us doing the weekly premium problem. Apparently I was traveling, so I guess I forgot or just didn't do it. So this is week 5. Let's take a look when it wants to load. When it wants to load. uh, yeah, alright, so it's one that we've solved before, but it's 272 closest binary search tree value 2. Given the root of binary search at a target value and an integer k, return the k values in the binary search tree that closest the target. You may return the answer in any order. You're guaranteed to have only one unique set of k values, okay? Yeah. Yeah, I mean, I think the first way that I would think about it is just getting a list of sorted things, right? And with BST, you can do it with a regular in order traversal to get a sorted order, and you could return K pretty quickly. But of course, the follow-up suggests that you want to solve it in less than or of n time, which is little of n, but I don't know why they didn't use it that way. But in any case, yeah, can we do better than that? I want to say I don't think so. It's a little bit weird. I mean, well, it depends on what you mean by O of n, right? You could say it's O of k, but k can be n. So in the worst case, it still would be not. In the worst case, it'll be O of n because that's just the size of the output, right? You have to return every value in the result, and that's going to be O of n, O of k, which is O of n, and that's going to be fast enough. So maybe there's something weird about the way that they phrased this, but in any case, if the BST is balanced, though, how would you think about it? The problem is also, well, oh yeah, well, if it's not balanced, the problem with finding the target is that it also takes linear time to find the target, right? Because you can imagine it's just your tree looks like a linked list, and if we have a linked list and it's order at the end, it's just going to be O of n to even get to the target, which you probably will have to do. Yeah. I mean, that said, if it is a balanced one, how do you solve in less than O of n time? I don't think I'm going to implement this because it does sound like a bit of an effort. But what you would do is binary search for the lower bound and upper bound, and because you know it's a balanced binary search tree, and maybe you do some maths with respect, or not maths, but you do a little bit bookkeeping on the nodes, right? And what I mean by that is that you have a binary search tree on the node. You go, well, there are x elements to the left, and minus x on the right, right? Minus one maybe for the so you normally note down the left and the right and the balance. That means that you're able to kind of figure out I mean, you just do the math, right? In terms of like, you're trying to find target, so you find out what number target is in the whole list, and then you just kind of like do a range query, right? Like for example, if target is the 5th number and k is 3, then you just do like 5 minus 3 and 5 plus 3 or something like that. Maybe it's off by 1, but you get the idea, right? And then you could just, from those bounds, you could just do a traversal type thing to kind of get it. So I don't know. I don't know if that's quite what they want, because then now you're able to get it in like 2 log n plus k or something like that, which maybe is faster than O of n. I'm not quite sure that's what they want. But for now, I don't know why this is hard. I mean, other than that, it is old. It is still a binary search tree though, so we could find a tree. And then, yeah, and then kind of just it's a little bit awkward, I think. I don't know. I mean, in that it's a little bit awkward in that, like, what you probably want is like a heap, right? To get the not even a heap, maybe just like a BFS type thing, right? And then just having a way to get the next number in the previous order, which there are ways to do it with like the Morris traversal and stuff like that, which I hate, by the way, because it just like it's a really weird algorithm in terms of like mutating the tree. But you can do it if you want. But I'm not going to. I think today I'm just going to cheat and I was a red eye. I wonder how I did last time. I'm just going to cheat and create an array and then return it. But I want to see if that's what I did last time. What did I do last time? Oh, I actually did do it with the crazy way. This is actually kind of what I was saying, but clearly it took me a couple of tries to get it right. Yeah, to get the next number and then the previous number, and then you just try to get the one that's closest. And the reason why you need to do something like that is because, for example, if your target is the smallest number and your k is 10, then it's actually not 5 on the left and 5 on the right, right? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I'm not going to do it this way. Definitely watch that video from last year because that's actually honestly it is what I'm thinking of. So definitely check that out and kind of work through the logic here. It is a mess that to keep track of the next number and the previous number, and like I said, and then from that you could kind of do a sort of a BFSE kind of thing to get the next number. But yeah, very involving, and I guess that's why it's hard. But today maybe I'm not gonna do it that way. So definitely watch this video. You could probably just search for it, or maybe if you haven't already, you could have done it. When would I have done this? But yeah, I probably did it in more earnest. And even then, though, like I said, it is still in the worst case O of n. So I don't know why they would say it. Yeah, that's what I was gonna say. I mean, that's what I did, right? But oh. Okay. I guess I mean, but that's what I did with the stack. I guess you could use a parent pointer. Yeah, I mean, that's basically what I did last time, right? I guess we could have used a parent pointer. But the problem with a parent pointer is that it doesn't allow you to get faster than O of n, right? And the reason is because you have to construct the entire tree. Or you have to like set the parent for the entire tree. So that's already O of n, so it's not faster than O of n, which is why I didn't bring it up. I guess the two stacks neither though. So I don't know, it's very weird this problem. Because in the worst case, like maybe like this is just wrong, right? So I don't know. I thought maybe I missed something from that analysis, but yeah. Basically everything on the hint just said what my code did, so the other video is probably really fine, or at least reasonable. But like I said, like even just keeping track of stack, I guess actually no, but I think keeping track of the stack, which is what I actually did. No, I mean I guess it doesn't go like if it's balanced, then you only go log n down. But the step to return O of k elements, right, which is at the worst O of n. So it's very weird. I don't know how I feel about this one. So that's why I'm just going to call it, and I don't know. So let's just do it the in order way, right? I'm going to be a little bit lazy. My apologies, friends. Feel free to get your money back for this video. But yeah. Oops. And process the current one. No, right. So then we just do it in order of root, and then make sure I don't suck too much, only a little bit. Yep. Just that it's gonna be sorted, right, and sorted. So then now we can say, yeah, the k number is closest to target. So then I'm just gonna be lazy. Right. Yeah, but basically we just do a binary search, right? So oops, instead of how do I code again? Right, so we have index is equal to this, and then we just kind of go left and right until right? So yeah, so left is equal to index, right is equal to index, right? So technically this could be wrong if k is equal to 1, I suppose. So maybe I do something like this. right? And while left is greater than 0, or maybe like so answer. Okay, I already said answer. So maybe r is equal for return. While length of r is less than k. Does it always have an MOS thing? Yep. Okay. So while is less than k, right? So if left is greater than equal to 0, we want to put in. How do I want to write this? Right. My keyboard's messy. How do I want to write this? But basically, you have to consider left and right, right? So maybe just write it out. Maybe that's fine. So if in this case both are valid, right? If both are valid, then if nums, I quit it right, which is terrible. Right. So if target minus this, I'm gonna put an absolute value just because I'm lazy, but it should. Everyone on the left should be smaller, so it should be fine. But yeah, this is right. This time it should be always negative because I'm just lazy. And then so if the left side is, or the right side is closer to the left, then we increment by 1, and then r dot append of right, else left, r dot append of left, right? Oh, I did it in the wrong order. Man, I am bad at this programming thing. And then we just kind of continue, right? Otherwise, then now just if left is valid, then r dot append of left. If right is less than n, same thing, but on the other side, obviously. And that's it, right? Hopefully. Missing argument x. Oh, huh. We did forget to search for the target. Man, sorry, friends. I am a little bit lazy today. Oh, well. Isn't it defined? We do. Oh, answer, not array. Whoops. Actually, array is probably better anyway. I am passing out. My apologies, friends. But yeah, I mean, the idea is probably right. I mean, we'll see if I get a wrong answer by accident. Like I said. But, if left is greater than equal to 0, how can it be out of bounds? Dong dong dong. That's weird. Oh, because left is equal to right? No, right is... So left is going to be 0. Well, this is probably wrong anyway. I probably should have done continue. Maybe that's it? I don't know, hopefully. Because this isn't trigger and then this thing. But okay, well, I don't know why I'm so bad today. Because this bisect left actually okay, so this alright, fine, right? So alright, fine. Which is that if index is greater than equal to n, then left is equal to index minus 1, else something like that. I guess I just didn't think about it because I just kind of put in index left. Yeah. Right, hopefully, come on, baby. Oh man, Target is 3. That sounds right. Oh, I see. Because it compares. So then the 3, because it doesn't go. Oh, so this is only the case if. Oh yeah, I think I messed up. Yeah, it should be probably something like this. And then minus 1, yeah, okay, fine. But yeah, as you can see, Today Larry's not a good boy. Alright, YOLO. Alright. Embarrassing, but not too embarrassing. But yeah, definitely take a look at the other one with the stack. You can kind of figure it out, but it's painful. It's 2 a.m. I need sleep. Larry needs some sleep. So yeah, that's what I have in this one. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.